Hello there. Hope you're doing great. Whew. All right, so here we are, Chapter 6. We're in 6-2 today. This is Systems of Equations. Super fun stuff. Super fun. We are going to solve, we'll learn two different algebraic methods. You'll like one of them inherently. You will enjoy and be better at one, but we need to be good at both because depending upon what our system looks like, it's going to say, hey, solve it this way, right? Or, hey, it looks like this. Okay, solve it that way. All right, so we have to be good at both of them. Today's method right here called substitution. Substitution. So we've done substitution all year long without even thinking about it. This is when we take something that we know, like a number, and we plug it back into something, right? We'll plug it back into an equation, and we'll see, hey, does this answer work, right? Some of us did this with inequalities, right? We took a number, we plugged it back into our inequality at the beginning and said, hey, does this give me a true statement? That, guys, is substitution, okay? Literally, it's nothing more than if I say 5x squared, and I want you to replace x with the number 4, even though that's not a great 4, okay? That's substitution. Plug 4 in for x, okay? 4 squared is 16, 16 times 5. Bam, there we go. We've done substitution, okay? That's what we're doing today, only. It's going to be with systems, okay? Again, here, if you're a step person, here's what you got, okay? Step number 1 is the most important. When necessary, solve one of the equations for one variable, okay? We talked about it the other day in class, guys. We have got to be very comfortable with this process of solving equations for a variable. I'm not solving it for a number, I'm solving it for a variable. We're rearranging that formula, that equation. That is my first step here, okay? Then we are going to take, right, hey, we're going to get x equals some expression. Then I'm going to take that expression, and that's what we're going to do the substituting with, okay? Remember, these are systems. These have two answers, x and y. So don't just do half the work, right? We solve it, that's step 2. Step 3 is getting the other answer, okay? All right, here we go. Bam, use substitution to solve this system right here, okay? This equation in slope-intercept form, this one in standard form. Step 1 says make sure one of your equations is solved for the variable. Doesn't matter which one. Well, this one's already solved for y. Okay, it says y is this expression, negative 4x plus 12. Okay, so what we are going to do, we are going to replace this y with this expression. Bam. Awesome, right? This is how it looks. The 2x, the plus, the equal sign, the 2, those all stay kind of where they are, guys. So it looks like this. 2x plus, and if you want to like bring this, it's not a bad habit. Some kids like to bring this in as that expression in parentheses, because here's the problem. Sometimes we're going to have a coefficient here, and then that's going to show up here, and then we're going to do distributive property, okay? So no big deal. We're good with writing it like this. I know this really means the same as just minus 4x plus 12, okay? Look what I've done, guys. I've taken a 2-variable equation, x and y, and I've now somehow changed it into a 1-variable equation that I can solve. Let's do that. 2x minus 4x, negative 2x. Okay? 12, we're going to move this to the other side, right? Subtract 12. That should turn into negative 10, and I get 5. Bam. One answer done, one more to go. You now need to go back to either equation. Doesn't matter if you use that top equation or the bottom equation. We now know what number x is. Now we will substitute that value back into the equation. I'm going to choose y equals, just because there's less work for me to do. Once I plug my number for x in, multiply and add, I'm all done. Okay? So y is equal to negative 4 times, sorry, this is just a 5, plus 12. All right, so this is going to be equal to, this is negative 20, right? Plus 12. And negative 20 plus 12 is negative 8. Bam. Good to go. All done. There's your two answers. If you would like, you can write them as an ordered pair, x comma y. Okay? Good to go. Remember, this system had one solution. If we were to look at this on a graph, guys, they're going to meet at the point 5, negative 8. So they're going to intersect somewhere down here. Maybe you got two lines going like that. I don't know. Just made that up. But that's what it would look like. Okay? All right. There you go. Don't worry. It'll get less confusing. Okay? Here's another example. Y equals 2x. 3x plus 4y equals 11. So is one of our equations already solved for a variable? The top one is again. All right? It says, hey, y is this stuff here. So, again, I'm going to replace this y with this expression. Notice we're taking 4 times y. So I want to take 4 times the entire expression. So think about parentheses. 3x plus 4 parentheses. Okay? That's why it's not a bad habit, gang. When you start substituting and you're taking this expression to put it in parentheses. Because eventually, like what if this was 2x plus 4? And you just wrote 4 times 2x and you never multiplied or distributed the 4 into that other term. Okay? Bad things happen. That's not this problem. Simplify this, guys. 3x plus, this is going to turn into 8x equals 11. Yeah, we're liking these. This is good. Okay? Bam. Halfway done, x is 1. Okay? Go back to either equation. Not going to matter. Again, I'm going to use the top equation just because that makes my life easier. Right? We know x is the number 1, so we're going to replace x with a 1. All we have to do is some multiplying here, and we're good to go, right? So 2. Again, if you want to write it as an ordered pair, you certainly can. Okay? There we go. So these are what we call simple substitution, right? One of our equations is already solved for x or y, and we're just substituting in that value, in this case 2x, into our other equation. What happens if that's not the case, my people? What happens if I get this? Okay? Well, here's where we need to solve one of our equations for x or y. Okay? How do you know? Like, who do I choose? If I look at the top equation, do I solve for x or do I solve for y? Or do I use the bottom equation and solve for x or solve for y? I don't know. Of course we know, right? Here's what you do. Okay? I always say look for the loner. And what I mean by that is look for the coefficient that is alone or that is positive 1. Do we have a coefficient that's positive 1? If we do, solve for that one. If we don't, do we have negative 1? Could we choose that one? Okay? So look at your coefficients. I have a coefficient of 5, 3, negative 2, and here it is, 1, positive 1. I want to solve the top equation for x. Okay? All I need to do is move this 2y over to the right. So we're going to add 2y. X equals negative 3 plus 2y. If you would rather write 2y minus 3, that's fine. It means the same thing. Okay? We're probably more comfortable with this one, so let's just get rid of that one. Okay. There we are. So now we look just like we did before. One of our equations solved for a variable. Now, go to your other equation. Going to replace x with this expression right here. Okay? That's what we're going to do. So it's going to look like this. 3 times. Again, this is where using parentheses will make a world of a difference. Okay? Go ahead. We're going to distribute and combine like terms. This will be 6y minus 9 plus 5y equals 24. Okay, combine your y's. Should be 11y minus 9 equals 24. Then we're going to add 9 over here. That should turn into what, 33? is 11y, or y equals 3. I'm running out of room. Okay, there we go. Y equals 3. So we're halfway there. Now, I can choose, guys, to use this equation, or this one. It doesn't matter, okay? None of them are particularly helpful, I don't think. Well, maybe this one is. Yeah, this one would be good. So let's do that. So we'll go x equals 2y minus 3. Again, we know what y is. It's the number 3. So a little multiplying, a little subtracting. Now we're going to know what x is. 2 times 3 is 6. 6 minus 3, oh, is also 3. Okay? There you go. Guys, we're going to have a lot of work on our papers for this, so do me a favor. Do yourself a favor. Show your work, circle your answer, or put whatever geometric shape you want to around it, or write an ordered pair and circle it. Look, these are all things, but they make life easier for us when we need to go find our answer. Okay? If at any time, guys, you want to try one of these on your own, you just pause the video and go. Go. All right, here we go. Here's this one. All right, my first trick doesn't work, guys. I'm looking at coefficients. 2, -4, 3, -1. I don't have any positive ones, but I do have a -1, okay? So that's what I would like to do. Let's solve this for y, okay? So 3, well here, we can, first step, subtract 3x from both sides. So I'm going to get -y equals -3x minus 12. Again, get rid of the negative. We have not solved this equation for y yet, so we must divide by -1. Y equals 3x plus 12. Okay? So there we go. All right, so now I know what y is. I'm going to replace y right here with this expression. Everybody else stays identical. Okay? So this is going to look like -4x plus 2 times this quantity for y that we're substituting in, 3x plus 12, and that will all equal 20. Okay? Keep solving that equation for x. Okay? Plus 6x plus 24. Guys, slow down and take your time, right? I was grading papers the other day. Some of us had some careless mistakes when we went to distribute. Right? Some of us added, some of us multiplied, we did subtract. We did everything but what we were supposed to, okay? So we should get -2 when we solve this equation. Again, come back. I'm going to use this one again. Y equals 3x plus 12. Right? We now know that x is the number -2. All right, so this turns into -6 plus 12, and so y is the number 6. Okay, so there's your two answers here. So again, very straightforward. Okay, solve an equation for x or y. All right, are they giving us any wrinkles here? No, this one looks fine. Okay, again, I don't have anybody that's solved for x or y, but it won't be terrible. Which one would you like to choose? You guys pick. I don't care. Look, coefficients, 2, 2, 1, and 1. We can solve the bottom equation for x or y. Won't make a difference there. So let's go ahead and do that. We'll solve for x. All right, so we'll move y over here. So this is going to say x equals -y minus 2. Okay, so here we go. Keep doing what we're doing. X. So now we're going to replace this x with this expression. -y minus 2. All the other stuff stays there. So 2 times this quantity, -y minus 2, plus 2y equals 8. Okay? We're going to distribute our 2 and then solve our equation for y. So -2y minus 4 plus 2y equals 8. All right. Oh, what? Whoa. What's going to happen here? Okay. You guys see it now? Look, what these cancel out. I go to combine my y's, negative 2y and 2y turn into nothing. Okay, so lights and sirens, right, should all be flashing inside your brains to say, hey, something special is happening. That special is a special case scenario, okay? Is negative 4 equal to 8? No. No, it is not. Okay? What does that mean? Special case scenario of no solutions. Okay? What could you tell me about this if we were on a graph? Right? What does no solution look like on a graph? Hey, somebody back there said it. Yes. Yeah, they said parallel slopes, right? Identical slopes. So if you wanted to verify that, guys, you could put both of those into slope-intercept form and look at their slopes, but I assume they're going to be equal. Okay. All righty, here we go. All right, finally we get something. All right, now, this is kind of where substitution falls down flat on its face, right? If you kind of analyze our two equations, I don't have a coefficient of 1 or negative 1 anywhere. 3, negative 2, negative 6, 4. Not very good. If we solve one of these equations for x or y, we can definitely do that. But it doesn't matter which one we solve. We're going to get a fraction somewhere. And I know your hatred for fractions. Okay? So this is where tomorrow's method, elimination, will come in, all right? But for now, we're going to solve this with substitution just to prove to you that it can be done. Just because we're going to get fractions, guys, I don't want you to worry. I'm going to solve this top equation for x. And guys, it really doesn't matter at this point. They're all bad. So 3x equals 2y plus 3. We're going to divide everybody by 3. Okay? X equals 2/3 y plus 1. Ugh. Okay, not the best fraction in the world, 2/3, but at least I didn't get two fractions, right? That's good. All right, so now we're going to, here, let me erase this. So now we've got our equation solved for x. Now we've got to use the other one. Everywhere I see an x, I'm going to replace it with this expression right here. Okay. All right, so negative 6 times this 2/3 y plus 1 plus 4y equals negative 6. All right. I was worried for a while. We're going to distribute here. I think we're going to be okay. Negative 6 times 2/3 is negative 4y. Uh-oh. Minus 6 plus 4y. Uh-oh. Maybe you see it. Maybe you don't. Combine your, hold on, this is a y. Combine your y's, what happens, folks? That's right. They cancel out. What are you left with? Okay, so we're left with this. Again, you've got to make sense of it. Just because your variables go doesn't always mean no solution, right? Make sense of what we have left. Negative 6 does equal negative 6. So if it's true, yep, infinitely many solutions. Fantastic. Okay? So there's how our two special cases would look, gang. Our variable is going to cancel out, and then we just have to understand what we're left with. Okay? All right. I'm hoping we get to word problems. Because, guys, this is really where we're going to, whoa, my, there's a lot of reading to do here. Okay? And we're going to spend a lot of time on word problems because there's all sorts of word problems that they can give us. Okay? And I can guarantee you these are going to be the ones that we see, all right, on our tests. So let's see what we got. Again, think about this, guys. We need to write two equations. Each one of those equations is going to have two variables. So we should have two variables. Like, let's just fast forward to the last sentence. I bet you we'll find out what our two variables are. how many memberships and how many single admissions were sold. So I haven't even read the problem, but I'm assuming memberships and single admissions are my two variables. Let's read the problem and figure this out. A nature center charges $35.25 for a yearly membership and $6.25 for a single admission. Right? So you can pay the $35 and you can get in all year, or you can just go one time and pay $6.25. Okay? It's up to you, whatever you want. Last week, it sold a combined total of 50 yearly memberships and single admissions for $660.50. Okay. Alrighty. Okay. So here are some helpful hints for writing these. Again, we know what our two variables are. So, our problems always say define a variable. Okay. So I'm going to say M is memberships. All right. And we can use A for single admissions. Okay. Okay. So here's my numbers. This and this one, I see a 50. That's all the numbers I see. Somehow I got to put all that together and get two equations? What? Are you serious? Yes, we're serious. Here's how it works, folks. Make one equation all about money. All about money. Okay? We have two different prices, right, for our two different variables. We know last week when we sold some combination of memberships and admissions, right, it was $660.50. Okay? So there's your first one. So I'm going to say 3525M, okay, plus 625A, and that's going to equal how much we made? $660.50. Okay? There we go. There's your first equation. Your second one comes from this sentence right here. Right? It comes from that highlighted stuff right there. And this is always the harder equation to write. So it tells me last week we sold a combined total of 50 memberships and single admissions. Doesn't tell me how many of each. It just says combined we sold 50. Like maybe I sold one membership and 49 single admissions, or maybe I sold 20 memberships and 30 single admissions, right? There's some combination of those that equals 50. So there's your second equation, right? It's going to be memberships plus single admissions equals 50. All right? Bam. All good here. Again, I'm not going to go through solving this one due to time constraints because I know you guys hate when my videos go more than 12 minutes. All right? But guys, we would solve this. We would choose to solve the bottom equation for either M or A. Okay? Like let's say we chose to solve this for M. So you get negative A plus 50. And then we need to replace M with this expression here in our top equation, right? And then we'd solve it. Doesn't matter that we've got some decimals in here. We're going to get good numbers, right? Because remember, we're dealing with memberships and admissions. We can't sell half a ticket or half a membership. So there's going to be some combination of numbers that works where we get whole numbers here, okay? So if you guys want to carry on and solve that, you can. In the meantime, we're going to do the same thing on this last one. These have got to be the single hardest ones to write, okay? These, again, solving these, we're going to get better. We're going to be fine, right? Look back at the previous 8 that we solved if you forget how to solve. Writing, whole different ballgame, okay? The chemistry mixture problems, I don't even like them, guys. I don't even like them. Okay, here we go. Mikhail needs 10 milliliters. Yeah, I said that right. Of 25% of HCl, which apparently is hydrochloric acid, for an experiment. Okay, that's what he needs. Apparently, This is bad. He has a bottle that's 10% of hydrochloric acid and a bottle of 40% hydrochloric acid, meaning like the mixture itself, it's not pure hydrochloric acid, like 100% pure. No. This one is diluted down to 10%. The other one's diluted to 40%. Okay? How much of each should he use to obtain the required amount of 25%? So he wants a 25% mixture, right? So he wants 25% to be pure hydrochloric acid, 75% I'm assuming is water or something else. Okay? Remember, he needs 10 milliliters. So we want to kind of do the same structure if we think about it. I want to make one equation out of all my chemistry stuff, right? All my hydrochloric acid, my mixtures, all that stuff. The other one comes from just kind of like, hey, we sold this many emissions. The other one comes from, hey, we need this much of it, 10 milliliters. Okay? So we've got our two variables, guys. I'll say x is our, no, we want a 25% solution. I'll say x is our 10% solution. I'll say y is our 40% solution. Yes, we're dealing with percents. No, we will not use them as percents. Make them decimals, okay? But we know there's some amount, right, of 10% and 40% that has to be in milliliters, right? So I want x's and y's, right, some amount of 10% and 40% in milliliters where it'll add up to 10 milliliters. Like maybe 1 milliliter here and 9 here. Maybe 2 and 8, 3 and 4, 5 and 5, 6 and 4, 7 and 3. Look, we've gone through almost all the combinations, okay? Now, the second equation is a little bit sneakier, right? A little bit tougher than the money example we just had. Okay, so we need, right, we are going to use these two numbers together, believe it or not. I've got 10% solution and a 40% solution, right? And so think back, right? If we think back to just all of the, like the pure hydrochloric acid that we want, right? So in our 10%, how much of that is pure hydrochloric acid? Well, 10% of it is. In our 40% mixture, how much is pure hydrochloric acid? Well, 40%. You guys are good. Well, when we make our 10 milliliters, which is a 25% mixture, how much of that is going to be pure hydrochloric acid? I don't know. Good. Here's what we do. You're going to take 10 milliliters, right, times that 25% mixture. That will tell me how many ounces of pure hydrochloric acid I need, okay? So we got to do a little bit of simplifying here, guys. Over here, 10 times 0.25. What is that, 2.5? I hope I don't mess that up. Okay. And can we now solve our equation? We can. Look, I understand we have decimals here, folks. We're not going to be worried about that. We're going to solve this top equation, okay? X equals negative y plus 10. Okay? Then we will substitute. I want you guys to try this one, okay? So again, if we're writing it, look, here's an x. Here's my x. We're going to replace it with this expression here. So it's going to look like this. Negative y plus 10 plus 0.40y equals 2.5. Okay? So you guys take it the rest of the way. I want you to distribute, combine like terms. Don't worry when you get a negative. It's going to be okay because you're going to get a negative on the other side. All right? And a negative divided by a negative, believe it or not, is a positive. Okay? So guys, take it the rest of the way. Hit pause. Come back. I'll give you the answer for what x and y are. Again, x is our 10% solution. Y is our 40% solution. How many milliliters we need of each one? Pause it. Oof. Welcome back. Okay, you guys solved it? Probably not. You're probably just watching it. We should get 5 and 5. Guys, if you did that right, okay? If not, look back, see where your mistake is. Maybe you got 5 and you didn't do the second one. Okay, if we solved here for y, again, figure out what x is, okay? Anyway, apologize for the length. Thanks for staying with us. Have a good day. Again, make sure we get to the bookwork and everything else. Practice, practice, practice. See you guys.